How do you answer real business questions using just basic statistics? In this session, we'll walk through 5 real scenarios using the Rossmann sales dataset, each tied to decisions that real retail teams face inside a company. By the end of this session, you learn how to speak the language of senior decision makers with data. You'll be able to translate real business questions into clear data analysis tasks, break down vague or broad executive prompts into manageable structured steps, and use simple statistics to uncover insights and guide smart business decisions. We start with the executive team's biggest concern: overall performance. Or, in other words, what does the sales data say? This is a common question that you will come across from the executive team. The executive team wants to understand the overall sales performance patterns across their stores. You'll hear a question like, what does the sales data look like overall? Are there any red flags we should be worried about? As an analyst, you need to convert this bigger business question into smaller chunks and in data terminology. So, behind this bigger question, are there any red flags? What does the sales data look like? There are underlying questions. What is the central tendency of data? What are the mean, median, mode of the data? What is our range, that is, upper and lower bounds of sales? Do most sales values lie within this range, or are there outliers? And do the extreme values represent genuine business performance or data quality issues? What business factors could explain the maximum sales figure? Let's begin with a quick look of our data. We are now on our raw Rossmann sales dataset. We have already cleaned the data and calculated some sales related statistics. In order to answer this question, what does the sales data tell us? We are looking at the measures of central tendency. We are looking at our minimum, maximum, mean or average, median, and mode. We calculated our minimum and mode and all these parameters for all stores in the previous session. And there we already found that the minimum and the mode are coming out to be 0. This was a clear indication that something is wrong. The sales should not be 0. And when we explored, we found out that there were many stores which had already closed down, and that's why their sales value was coming out to be 0. This in itself is a first good insight. You could have considered this as a red flag that why our minimum sales and our mode of sales is coming out to be 0, and when we have cleaned the data, we have removed all the closed stores, then we are able to calculate our statistics again, and now we have our minimum value of 612, the maximum is 38,000, which is quite high, and our average is 6694, median is 6282, and mode is 5200. So after calculating these values, we look deeper further into these parameters. Now we are noticing that our maximum sales, 38,000, is quite higher compared to 6,694, which is the mean. This is something that you need to highlight to your executive team. Next, we notice that the mean and the median, they are quite similar to each other. If we check out the difference between the mean and the median, it is coming out to be around 412 euros. So imagine for several thousands of stores with several thousands in daily sales, a difference of 412 between the median and the average is not that high. And this actually indicates that our data is fairly balanced. It's not skewed, it's normal distribution. Again, by checking out these values of mean and comparing them with median, we are able to identify that there is no red flag in our data. This is a good first step, but this alone is not enough. We also need to identify what is happening with this 38,037 maximum sales. How many stores are there which have really such high values? Or how many stores are there which have really low values? For this, recall that we have the central tendency measure, which is the quartile. We can use the quartiles and calculate the range of our data. This is something that we have already done. We have our first quartile, second quartile, third quartile, and we have already calculated our interquartile range. Using these values, we were able to identify our lower bound, which is 75.5, and our upper bound, which is 12,847.5. So anything which is within this range is a normal value, and anything which is outside of this range is an outlier. And clearly, our maximum value, 38,037, is an outlier because it is outside of the range. It's above 12,847. But this might not be the only store which is beyond this range. So we would like to find out how many stores are there in total, or how many data points do we have in total, and how many out of these are actually an outlier. If you recall, we calculated our uh, box and whisker plot. That actually gave us a quick indication. So most of our data is within the range, but there are quite a few data points which are outside of our range. And these are our outliers. So let's count them. How do we count them? First of all, select any one column and look at the count down there. It's 75,592. So we can actually make a note of this, that we have total open stores which are, let's say, 75,592. Now let's count how many stores are there which are an outlier, not just stores in individually. Rather, let's start with how many data points are there, because one store might be having multiple outliers as well. To do this, what we can do is apply a filter, go to the data and apply a filter. And here in sales, you can check not all of the data points, rather only those data points which above are above range. So 12,847. So when we do this, we notice, if we check the count again, it's 1,949. So the open stores for which the sales is coming out to be more than the threshold is 1,949. Let's note this down. 1,949. So open stores with sales outside range. And now we can do some quick calculation to see how much is the percentage of open stores outside range. And here we can check that this is equal to open stores divided by total stores into 100, and this is coming out to be 2.57%. This is actually quite a low value. You can, in other words, say that the number of outliers, the percentage of outliers, is only 2.57%. This is something which you should not be worried about. Yes, of course, we need to learn from those stores which are making a lot of sales, but there is nothing to be worried about because the number of outliers, the percentage of outliers is not too big. Anything bigger than 10% will be a problem. This will be something that you would like to look into. If we go back to the other side of the threshold, so anything which is less than 75.5 is also an outlier. And this is indeed a problem that we will have to be worried about because these stores are performing so bad that they are below the lower threshold. So let's check these out. So now instead of checking, first of all, let's remove the previous filter and now select anything which is less than 75.5, and we see that there is actually we missed out the point, and we notice that there is actually no store which is less than 75.5 in sales. And this is actually a good thing. We don't have any such low performing store. Rather, we have all the stores which are within the range or in the positive direction. So now we have a full picture. We can clear up our filter to get all our data back. But now we have our full picture. We now know that our data is normally distributed. There are some outliers, there are a few outliers, but nothing to be worried about. And these outliers, we can later on see what is the impact of different parameters which is causing those high scales, high sales. And uh, overall, there is no red flag in our data or in our sales. Now that we have ruled out any major red flags in the sales data, we can move towards more strategic questions.